Geometry Common Core Regions Review, video number 8. So in this first one here, we have a proof where they've actually done most of the work for us. We just got to kind of fill in the blanks. So first, we're given this set of givens. We've got that we have triangle ABC with AEC as one line segment, BDE as another line. We've got two congruent angles here is with AB. Let's see what this is, ABE and CBE. So these are congruent. We've got angles ADCE along here. These are also congruent. And then they tell me that BD is congruent to itself. So that is going to be the reason for reflexive property. So anytime you have a line or an angle being shared by the same thing, you have the two of those are being with the property of reflexive property. We've also got supplementary angles, which they've given us because linear pairs of angles are supplementary. And if we've got these two sets of angles here that are linear pairs, that's BDA and ADE, right? These two are going to be supplementary and these two are going to be supplementary. The question then states that these two angles here, which would be ADB and CDB, that means that those two things are going to be congruent because supplements of congruent angles are congruent. So basically they're saying if whatever these two angles are, they are the same. If I take that away from 180 on either situation, I'm going to have two resulting angles that are the same as well. All right, so that makes these two triangles here, ABD and CBD, congruent. That's angle side angle. That would be these two triangles here. And then it says that AD and CB are congruent, along with AB and CB are congruent. Well, those are just the parts of these two triangles, which they have indicated here. I'll highlight. So we've got this triangle here, and this triangle here is what they just stated are congruent. So therefore, anything that's any resulting parts of those triangles are also congruent. So that makes them congruent by CPCTC. Corresponding parts of congruent triangles are congruent. And last but not least, the proof as to why BDE is in fact a perpendicular bisector of AC. Now, it's a little wordy here how we can go through this, but essentially, right, what we have here is that we've got this big triangle is in fact an isosceles triangle because we just proved that these two sides are equal. So if I have an isosceles triangle with a line segment coming from the vertex, that makes this a median, right? The fact that these two angles are equal, right, means that it's an angle bisector. And if I have an angle a median of an isosceles triangle, right, and these two things are equal, then that means that I have an altitude. So if BD is an altitude, that means that AE and EC are congruent, and that would result in this being perpendicular to AC, making it, in fact, a perpendicular bisector. So that one's it's a little wordy, all right, but that is the general concept here. What they're really looking for is that fact that I have an isosceles triangle with a median. We get that rare special case with isosceles triangles and equilateral triangles that if you have a median coming from the vertex in either of those situations, you actually, in fact, still have more than just a median. You have an altitude as well. All right, next question. In here, we have this pole. This telephone pole is being anchored by a stake. It's 15 feet from the ground. And Jamal places a 6-foot wooden pole under the support wire pole that is parallel to the telephone pole. So that's important. We have the fact that this and this are parallel to each other. All right. We're doing so such that the one end of the pole is on the ground and the top of the pole is touching the wire, as we have indicated in the picture. He measures the distance between the bottom of the pole and the stake in the ground. So he's got this mark here. Jamal says he can approximate how high the support wire attached to the telephone pole by using similar triangles. Explain why triangles are similar. So in fact, we do have similar triangles. We don't really have a lot of math to have to do here because the fact that I now know that these are parallel that means that their corresponding angles are also equal. So I have here this angle and this angle would be corresponding, so that makes them congruent to each other. That also means that this one and this one are corresponding. Now, again, I know a lot of people want to say, well, these two must be right angles. Again, you're assuming that this is this pole is perpendicular to the ground, which it should be, but we don't have that information. So as long as we know that they're congruent, that's really all we need. So either one of those pairs of angles would be helpful. Having both of them is also going to give me similar triangles. But we also have this third one here because this is being shared by both triangles. So reality is I probably would indicate that I have this one that I just indicated as red here, this red angle, and either one of the two blue pairs of angles. And again, as long as I have two pairs, I have enough to show that they are congruent. So, I mean, similar. So I can now say that, yes, these two triangles are similar because one pair of angles is congruent by reflexive property. That would be my red angle here. I have a second pair of angles congruent by corresponding angles of parallel lines, which again, either pair of blue angles is represented there. Therefore, the two triangles are similar by angle-angle similarity. So really not a bad one. And if it helps you, there's nothing wrong with labeling the diagram, right? Actually going off the side here, labeling each of these, points, coming up with names, naming the angles. If it helps to describe the process, that's fine. But again, as long as you're indicating here that we have at least two pairs of congruent angles, we now know that these triangles are in fact similar by angle-angle similarity. Last but not least, we've got this third question which says, which three-dimensional figure will result when a rectangle 6 inches long and 5 inches wide is continually rotated about the longer side? Well, right away, the fact that I've been told that we have a continuous rotation here, that tells me that I'm going to have a circular portion going on, because if I'm continuously rotating, that means something's going around something. So I'm going to get that circular aspect. So looking at my answer choices, I can kind of eliminate immediately A and B because those are rectangular prisms. I'm not going to have any circular side portion to that. So that's going to give me a limit. So again, if I just kind of sketch down here, I have a rectangle, right? And it's saying it's rotated around the longer side. So let's just say hypothetically we're rotated around this side right here, this blue one, right? If I think about each of these points, right? If I rotate here, that point's not going to move. It's going to stay there. This point here, if I rotate, it's going to go like this, right? What happened there? Where'd my pen go? So as I rotate, right, it's going to look like that. Same thing over here, all right? So I'm going to get that, right? I'm going to get that cylinder-like shape because, again, this line would be connected over here as well. So now I've got this cylinder-like shape, right? Circle, circle, here. So there's my cylinder, right? And again, as we've already indicated before, I have, this is in fact 6 feet, and this was a 5 feet, or I'm sorry, inches long. So that means I have a radius of 5 and a height of 6, right? So if that's the case, based on my answer choices, that gives me C with a radius of 5 and a height of 6. So it definitely helps to sketch out some of these pictures, these descriptions as to going when you're trying to figure out what these three-dimensional shapes are going to look like. because again, it's sometimes hard to envision in your head. So if you sketch it out, it kind of helps out to be able to see. So hopefully you can see that I have, again, this cylinder kind of thing here. Again, you could envision it standing up this way as well, right? It would look like this if you wanted to do it that way. So whichever one helps, it doesn't matter, but again, C is the answer.